Good evening, class. Today we're going to be continuing our lesson on different chemical reactions. So, I have a chemical reaction here, and I'd like you to determine if it's a combustion reaction, an acid-base reaction, or an oxidation-reduction reaction. Now, the chemicals involved here are solution A and solution B. Solution A contains a chemical called luminol. Luminol is a compound that will emit a light when it is react with another specific compound of potassium ferrocyanide and hydrogen peroxide. Now, potassium ferrocyanide is a specific metal that's called a catalyst. Now, we've gone over catalysts. Can anyone explain to me what a catalyst is? Yes. Exactly right. A catalyst is a substance that lowers activation energy. So lowering activation energy. We all know what this means. Lowering activation energy means that a chemical reaction can take place, and the chemical reaction requires less energy to start. Now, certain chemical reactions require catalysts to start because their energy threshold is too high. Now, I want you to observe this reaction here and determine what is happening. Is this a combustion reaction, an acid-base reaction, oxidation-reduction reaction? So we're going to mix solution A and solution B, the luminol plus the potassium ferrocyanide and hydrogen peroxide. Now, as you see here, the solution, when mixed, emitted a bright light. Now, from our previous knowledge, previous units, what do we think type of reaction this is? I want you to take a minute and think with your partner. Okay. So, what type of reaction is this? Yeah, okay. Why do you think it's an acid-base reaction? Not really sure? Okay. Anyone else have another guess? Yes. Oxidation reduction? Why do you think so? Because of why? Well, that's right. You're correct. This is actually an oxidation reduction reaction. Now, I drew what we all know to be an atom or structure with a nucleus, different atomic orbitals. Now, I'm not going to go into too much detail as to what's happening here because this is what's called a multiple stage reaction. So it has multiple different parts in reacting simultaneously to produce the light. But what's happening here is this, for our purposes, this is an atom of luminol. And what's happening is an electron is moving down atomic orbitals. And then, in another stage, the electron moves back up and emits what's called photons, or light. And that's the light we perceive from the reaction. Okay. So this is an oxidation and reduction, or OxRedox reaction. So what this means, when a compound or an atom is oxidized, this means that it loses electrons. And when an atom loses electrons, it will gain in charge. So the charge on the atom will become more positive. And when a substance is reduced, does anyone have a guess? Exactly. It will gain electrons, the opposite of oxidation. And so, since it's gaining electrons, it will reduce in charge. So, always remember this. Write this down. Oxidation loses electrons, gains in charge. Reduction gains electrons, reduces in charge. And there are two more terms. Reduction agent and oxidation agent. Now, a reduction agent donates electrons. So a reduction agent gets rid of electrons, donates them. So the oxidation agent has to receive the electrons. So a substance that is being oxidized or losing electrons, losing, I'll just represent that as an L, electrons, is the reduction agent. So, in a chemical equation, the atom that is losing electrons is being oxidized and is the reduction agent. It's a little backwards and confusing. But if you think about the meanings of the words or the terms, it will make sense. So, since reduction is gaining a G, I represent it as G, gaining electrons, it is the oxidation agent because it is receiving the electrons. Okay? Everyone got this down? Perfect. Now, with that knowledge, let's take a look at a reaction here. So we have an atom of potassium, K, plus chlorine, Cl. Kc moves to K, it reacts to form potassium chloride, KCl. Now I want you to think with your partners. Is this an oxidation reduction reaction? Look at the charges on here. Look at the charges in the product. Pay attention. What is this an oxidation reduction reaction? Yes. So you think this is an oxidation reduction reaction. Why do you think that? Because of the charges on here. Well, okay. Let's look at the charges. So, as we see, potassium is a positive charge, chlorine is a negative charge. We look at potassium chloride. chlorine, the overall charge on the compound is 0. Now, we always know, according to the periodic table, that chlorine is a -1 charge at all times. Chlorine is a -1. So, let's look at it here. -1. To reach a overall charge of 0, what would potassium's charge have? Yes? Positive. Exactly. So, potassium's charge is +1, chlorine's charge is -1. But in the reactants, potassium's charge is +1, chlorine's charge is -1. So this reaction is actually not an oxidation reduction. It's not an OxRedox reaction. All right. So what we did there was we calculated the oxidation numbers. So oxidation numbers are the charges that correlate to each atom in a compound. So let's calculate the oxidation numbers for another compound. Let's look at MnO4-. Let's break this down into a mathematical equation. So MnO4-. So we know that the overall charge of the entire compound has to be -1. So, judging from our knowledge of the periodic table, what is the charge? We know the charge of one of these two atoms. Which one is it? Yes? Oxygen. Exactly. What's the charge of oxygen? -2. But hold on. There's 4 oxygens. So we have to multiply -2 by 4. And we all know that gives us -8. So, -8 equals 1. What does the charge for the magnesium have to be? Sorry, the manganese. What does the charge of the manganese have to be in order to equal -1? Yes? 7. Exactly. It has to be +7. Because 7 minus 8 equals -1. So the charge for the manganese, or the oxidation number, has to be +7. Everyone got that? Good. Let's calculate another oxidation number. This time, let's calculate Cr2O7 -2 charge. So, break this down to a mathematical equation. Overall charge is -2. There's 7 oxygens that have a -2. So, there's 2 atoms of chromium. So what is the charge of chromium? Well, 7 times -2, -14. Now, what times 14, or what plus 14 would give you -2? +12. Oh, there's a 2 there. So what do you think we should do in order to determine the charge of chromium? Remember, there's two molecules or two atoms of chromium. Exactly. We divide it. So 12 divided by 2 gives us 6. Positive 6. So positive 6 times 2 will give us 12. 7 times negative 2 is 14. 12 plus minus 14 equals negative 2. So the charge for the chromium has to be positive 6. And the oxidation number has to be positive 6. All right, let's move on. So, now that we know oxidation and reduction reactions, we know oxidation reduction agents, and we know how to calculate the oxidation number. There's one more thing in oxidation reduction reactions that we need to know, and that is half reactions. Half reactions is breaking down the whole oxidation reduction reaction into two separate reactions, giving us more detail about the electron movement. Now, I'm going to map this out so it makes sense. So let's take let's see here. Right here. Okay. So let's take a molecule of sodium plus chlorine to give us sodium chloride. Now, this isn't the same as the potassium reaction because we have two neutral molecules. Solid sodium, sorry, that's terrible S, chlorine gas. So they're both neutral charges of 0. But that's not the case in sodium chloride. So, what should be our first step? Determining the oxidation numbers. Correct. So, we all know that the charge is 0. It's a neutral charge. What's the charge of chlorine? Look at the periodic table above you. -1. So, to get a charge of 0, the sodium has to be +1. So, we got the charges of sodium and chlorine. Now, to break this down into half reactions, this is the complete reaction. We got one electron moving about. So let's break this down. So let's start with the sodium. So the sodium is going from a neutral charge of 0 to a positive charge of 1. So what is happening? Is the sodium being oxidized or reduced? It's going up in charge. So, correct. Sodium is being oxidized. So that means it's gaining charge, losing electrons. So we put down the positive sodium molecule. Plus, to represent the electron movement, we write 1e minus. That means one electron is being moved. Now for the chlorine, it's being reduced, so we go Cl plus 1 electron, Cl minus. That is being, so sodium is being oxidized, chlorine is being reduced. All right, that's all the time we have for today. So I would like you to complete these exit slips here, and I will hand out a worksheet for everyone to take home. Okay? Thank you very much.